Okay, so on this problem, they're giving us an x squared expression, x squared plus 10x plus 124, at least is mine. And they want us to rewrite it to look like this. So now I know this might seem weird, like why would we take this thing and rewrite it to look like that? Well, it turns out this form right here is actually super useful. In higher math and science, we like to have things in what's called completed square format. This is called completing the square, meaning you make it parenthesis to the second power, right? That's the square, second power. So they're saying make it that way. Now let me show you what we mean for instance. I don't want this to be totally mystery. If I had, well, you know what? Let me not waste your time. Well, let's just get right into it. So basically, here's how you do this. You take this expression right here. Let me bring it down here. X squared plus 10x plus 124. And I want to change the way it looks. It's kind of like plastic surgery. We're removing the wrinkles, but it's the same person when we're done. We're making it look different, but it's going to be the same value it was before. Well, how do you do that? Well, basically what you do, there's like a magic formula. Let me show it to you. Take this middle number right here. This is the B. You know, we call these ABC. You're quite familiar with that now, the ABC, right? We go over on the side and we take the B, the middle term, divided by 2 squared. Okay, so I'm going to take what's the B? In my case, it's 10 divided by 2 squared. 10 divided by 2 is 5. 5 squared is 25. Okay, so what do we do with that? That's the magic number that we both add and subtract. Let me show you. So we have x squared plus 10x, and then right next to the 10x, right after the 10x, we put in a plus 25 and a minus 25, and then you go back to the 124. So notice I haven't changed anything, right? This is a big 0, isn't it? Right? By putting that in, I haven't changed anything. That's why I call it plastic surgery. Same person, it just looks different, right? Wouldn't you agree? This is the same value as the original one. We haven't changed anything. We just made it look different. Now, why? Why are we doing this weird thing? You know, you're probably like, I get it. It looks different, but why? Well, because now these three will factor as double parentheses. Well, how so? Can you see it? X is in the front. X times X is X squared. What times what needs to go in the back to make 25? Remember, it's multiply, add, multiply, right? What times what's 25? 5 times 5. And both plus adds to be 10 in the middle, doesn't it? Okay, great. Yeah, so what? Then just bring down the minus 25 and the plus 124. Okay, and notice what happened here. It not only factored, like parenthesis, you know, but it's the exact same thing twice, isn't it? It's identical twins. Okay, so what? Well, that means we can do what? Make it second power. This is what we were wanting to do. And then just combine the other numbers. What is, just use your calculator, what is minus 25 plus 124? I think it's 99. And we're done. We did it. What did we do? We took the original expression, which did not have parentheses, to the second power. And by adding 25 and subtracting 25, that was the perfect number, which we found over on the side with the b over 2 quantity squared little magic trick. We found the perfect number to add and subtract, so we didn't change anything really. And that when we added it, then the first 3 terms would factor 2 parentheses, identical, so that's squared. And so we made it x plus 5 squared plus 99, which is really the same as the original. I can prove it here. Not what we will actually, let me finish answering the question. They told us to make it x plus a squared plus b. X plus a squared plus b. So what's the a? 5. What's the b? 99. The a is 5. The b is 99. We're done. Now, let me prove it's true real quick, just to show you. I want to make sure you're clear on what we just did. If I was to take this expression down here, and say, what is x plus 5 squared? Put that here, actually. What is x plus 5 squared plus 99? Well, it's x plus 5 times x plus 5. I just want to prove to you that it's really still the same. And if you distribute, you know how to do this. X squared plus 5x, boom, boom, plus 5x plus 25, and then you get the plus 99. Add these up, it's 124. Add these up, it's 10x. Oops. And look at that. Check. It's the same as the original expression, isn't it? See that? I'm just proving to you that what we've written here is just another way of saying the same thing. And in higher math and science, it's a way that's very useful. In fact, you've seen a little bit of it already. Remember how when we were graphing the U-shapes, and that'll be on our chapter 3 exam. Well, remember when we graph U-shapes, how easy it is to find the middle if you have it in this kind of format with the parentheses squared. I don't know if you remember that or not. That was about 3 sections ago when we did the graphing. But remember, you just take opposite and then same, and you can right away find the center of the U-shape. It makes graphing U-shapes super easy. It does a million other things as well in higher math and science. So that's why we like to change things to be in this format. And that's called completing the square, making it parentheses squared without changing the value. There we go.